let's get on to it. Last episode, we acquired the parametric general normal line equation, which is y equals negative x prime t over y prime t times x minus x of t plus y of t, where the negative x prime t over y prime t is the slope of the line, and x of t and y of t the point of the parameter to draw from. Moreover, we found that the equation and the parameter xt, yt both depend on the variable t. So by giving t a value, say 1, we can locate a point on the parameter when t equals 1, and at the same time, draw a line perpendicular to that same point. Now in this video, we take the next step to finding the parametric pseudo-focus by finding the general point called the center of curvature. The center of curvature is essentially the quote-unquote infinitesimal intersection of two very close normal lines. Meaning if we had a normal line on a parameter and then have another normal line approach but not coincide the first normal line, then the lines still intersect at some point since they are still not parallel. And that intersection point is what's called the center of curvature. And hey, center of curvature sounds awesome, but just in case, I would want to call it CoC if I want to get straight to the point. But I want to be careful not to say it as a word, you know? Alright, let us now take the definition of the CoC and translate it in the mathematical context with what we know so far. So first, to find the CoC, we need two different normal lines. The normal lines can be any value we want, but we will go with a normal line defined by some value a, say y equals negative x prime a over y prime a times x minus xa plus ya. And then another normal line with the value of b, that is y equals negative x prime b over y prime b x minus xb plus yb. Okay, after that, we now want to find their point of intersection, so what we do is smack the two together with the equal sign to say that we need to find the point where these two lines meet. And now, we solve for x in this equation. But before I do that, I just want to say that algebra parts are overall not that important if you want to get to the meat of finding the PF. But the reason I'm just firing away with that algebra is because I want you, dear viewer, to sharpen that algebra brain with some tough practice. And with some tough practice, you would get used to polishing your mind clean of rough edges. So if you're just here to witness me arranging a hoarder's syndrome of numbers together, then I don't mind you skipping these mind-smoothening parts of the video. Either way, let the smoothening commence. So one way to make my algebra a bit less daunting is to shorten my variables. It goes like this. xa becomes x sub a, ya becomes y sub a, x prime a becomes x big A, y prime a becomes y big A, and the same can be said to the b variables. With that, let's write down our shortened equality. Here it is. So, a first move would be transferring ya to the right, and then we factor each of the slope fractions from each side, where left factor goes by negative x big A over y big A times x plus x big A over y big A times xa, and the right factor goes by negative x big B over y big B times x plus x big B over y big B times xb. Okay, next we transfer this x big A over y big A xa to the right, and then transfer the negative x big B over y big B x to the left. After that, next we then divide this entire inner factor and unleash it to the right side. Well, we could stop there, but the next direct step is to multiply everything by y big B and y big A to get rid of those nasty denominators. This is our last step, so our result for x would be xb, x big B, y big A minus xa, x big A, y big B plus yb, y big A, y big B, minus ya, y big A, y big B, all over x big B, y big A, minus x big A, y big B. Oh geez, this is way worse than the function version. Here we got the xxx and the yyyy, and then the bba and the aab. Anyways, this here is the x-coordinate of the CoC. So what that means is, there's even more room for smoothing for the y-coordinate. To solve for the y-coordinate, we choose either normal line equation and take this whole bunch of x to substitute for that equation. Alright, let's choose the b equation. Here it is. Okay, so first off, let's include the xb to the fraction, where we multiply it by the denominator, where it becomes negative xb, x big B, y big A, plus xb, x big A, y big B in the numerator. Alrighty, next thing we do is cancel. And hey, since the equation is messed up, let's play find the canceling like terms. You have 5 seconds. Next, we include the yb inside by multiplying it by negative y big B over x big B. After that, we then multiply the term we included by the numerator. Take a look. Then a bit of simplification to the 5th term. Again, we have another cancellation to the 5th and 2nd term. Now notice, we have y big B's on every numerator term. Let's cancel that to the y big B of the outside factor. Lastly, let's then multiply the negative x big B to the numerator. And since it's our last step, the equation out loud is y equals xa, x big A, x big B, plus x big B, y A, y big A, minus x big A, x B, x big B, minus y big B, y B, x big A, all over x big B, y big A, minus x big A, y big B. Okay, now let us prepare for the real part of the algebra, whether this giraffe's reach of expressions are correct or not. To do that, I inputted the 2 normal lines defined by a and b, and then plot the big bunch together in a coordinate, and then... oh? Okay, what if we play around with a and b? Oh, turns out the x and y expression we got are correct. Yes! So this point right here is the intersection of 2 normal lines on a parameter. Therefore, this means we have found the center of curvature of a parameter. Just kidding, we haven't yet. Indeed, we have the intersection of 2 lines, but not the infinitesimal intersection of 2 lines. So that means we have to go for another wave of algebra, right? Well, consider your soul saved for this video, because we're cutting that portion of work to another video. So, prepare yourself. See you next video, folks. The entire inner factor and unleash it to the right side. And unleash it to the right side. Unleash it to the right side. Unleash it to the right. Unleash it. Shit.